Assalamualaikum and hi everyone. Our group will present to you about Microsoft Windows operating system. This is the list of team members which consists of 6, 2 girls and 4 boys. What is Windows? Windows is a multitasking, multi-user and graphical user interface-based operating system.
What is a process? The basic unit of software that the operating system deals with in scheduling the work done by the processor. Can be defined as software that performs some action and can be controlled by a user, other application, or operating system. A process contains one thread which is composed of first, a unique identifier, second, content of a volatile set of registers indicating the processor state, next, two stacks used during the thread execution, and last, a private storage area used by a subsystem.
Okay, hi. My name is Demilaji Idris. So, for my part, I will present about process creation. Process creation. Process creation, the fundamental Windows process management function is create process, which creates a process with a single thread. So it specifies the name of an executable program file as part of the create process call. And it is common to speak of parent and child process, but Windows does not actually maintain this relationship. So, furthermore, process creation is achieved through the fork system call. So next, so this is three things about creation process. So the first one, creation process has 10 parameters to support its flexibility and power. The second one, it is appropriate to explain all the create process parameters. Lastly, create process creates a new process with a single primary thread, which might create additional threads. So that's all from me. Thank you.
Now, I will talk about thread. In process management, there's a thread. Each thread in a process shares code, global variables, environment strings, and resources. Each thread is independently scheduled, and a thread has the following elements. Firstly, a stack for procedure calls, interrupts, exception handlers, and automatic storage. Second is thread local storage TLS. It is an array-like collection of pointers, giving each thread the ability to allocate storage to create its own unique data environment. Thirdly, an argument on the stack from the creating thread, which is usually unique for each thread. And lastly, a context structure maintained by the kernel with machine register values. So next, there's two types of thread. First is a single thread. The actual data forming this context varies from one processor to another. The kernel schedules threads for execution on a processor. The process is like a container for the global variables, the environment strings, the heap owned by the application, and the thread. Thread is what exactly executes the code. So, on the left side is the example for the single thread. So next we move to multiple thread. Multiple thread is a process that can have as many threads as there are CPUs available. Overhead incurred by a thread is minimal. To split a single application into multiple threads, it is also possible for several different threads to modify the same global variables independently of each other. So next, to prevent that, Windows operating systems include synchronization mechanism to give exclusive access to global variables as this multi-threaded process are executed. So the advantage of multiple thread is the data is retrieved faster when the system has several threads of execution that are searching an array simultaneously. So it must be designed carefully to minimize contention, such as when two CPUs attempt to access the same memory location at the same time. So next is the client-server applications. CPU intensive for the server. So actual query is managed by the server's processor. So A Windows multiprocessing environment can satisfy those requests by allocating additional CPU resources.
So now I will talk about interrupt handle. So interrupt handle is the process that runs when interrupt is generated. Interrupt is a signal sent by hardware or software for processing the processor. So the CPU will give access to interrupt handler after the interrupt was generated and change its priority from the ongoing process. All of this whole process is called interrupt handling. The interrupt handler, also known as interrupt service routine ISR, which it will handles the request and it sends it to the CPU. After ISR is done, the process will continue.
Next, I will present to you about the type of interrupt handler. 1. First level interrupt handler. It can quickly service an interrupt and schedule the second level interrupt level if needed.
Now we will go to the next slide. Next slide is interrupt service routine ISR main feature. What is ISR? ISR is the others name from the handler interrupt. Okay, the main feature of the ISR is interrupt can occur at any time and they are asynchronous. And ISRs can call for asynchronous interrupts. An interrupt service mechanism can call the ISRs from multiple sources. ISRs can handle both maxable and non-maxable interrupts, and instruction in a program can disable or enable an interrupt handler's call. The nested interrupts are allowed in ISR for diversion to the other ISRs. ISR at the beginning of the execution will disable other devices' interrupt services. After completion of the ISR execution, it will reinitialize the interrupt services.
So how to handle interrupt? First, we need interrupt controller. Interrupt controller is to generate interrupt to CPU. So before interrupt was generated, CPU checks for pending program. So they will continue the pending program if it doesn't have any interrupt. And what if we have an interrupt? So the current program is safe according to the given to the interrupt handler. So how do we need to handle the interrupt actually? Given the possibilities that there are many interrupts. That's why we need an IVT, or we call as interrupt vector table. It is the interrupt number and its corresponding set address vector table to know which interrupt is assigned. And next, we need to go to the ISR, which is called interrupt service routine. CPU will get to know the base address of the process to handle respective interrupt based on their IVT just now. And the next part is the execution. The interrupt handler will now execute the necessary set of instruction given on the interrupt. Then after the execution is done, the suspended process will be continued.
That is all our presentation. Thank you.